Something strange may be happening beneath the ice of Jupiter's moon Europa, and the possibility is serious enough that even NASA scientists have started paying close attention.
Because of this giant ocean, I think that Europa is actually one of the best places to look for life beyond the Earth.
From the outside, Europa doesn't look particularly special. It's just a frozen world, a smooth white shell of ice drifting around Jupiter, the largest planet in our solar system. But for years, scientists have suspected that beneath that quiet surface lies something very different. A vast ocean. An ocean that may contain more water than all of Earth's oceans combined. Recently, new observations have revealed chemicals and energy sources that shouldn't be there unless something is happening deep below the surface. And that raises a question scientists are now beginning to ask very carefully. Are we looking at the first real hints of alien life? Now, moments like this are exactly why simulation hypothesis exists. We try to understand what the universe is really doing, even when the answers sound like science fiction. Because sometimes the strangest discoveries turn out to be real. If you haven't subscribed yet, go ahead and do that real quick so we can keep exploring mysteries like this together. Now, Europa wasn't always considered a place where life might exist. For most of human history, it was just one of the many small moons orbiting Jupiter. In fact, Europa was discovered all the way back in 1610 by Galileo Galilei, the same astronomer who discovered Jupiter's other large moons, Io, Ganymede, and Callisto. At the time, all Galileo could see was a tiny dot of light moving around Jupiter. Nothing about it looked special. And even when telescopes improved, Europa still didn't reveal much. From a distance, it just looked like a smooth white sphere. No mountains, no craters, no obvious signs of activity. And that last detail actually turned out to be the first clue that something unusual was happening there. Because when scientists finally started studying Europa up close, they noticed something odd. The surface looked too young. Most moons in our solar system are covered in impact craters from billions of years of asteroid collisions. Our own moon is full of them. Europa is. Its surface is strangely smooth. That means something must be constantly reshaping it, something beneath the ice. But the real turning point came in the 1990s, when NASA sent a spacecraft called Galileo to orbit Jupiter. This mission spent 8 years studying the giant planet and its moons, and when it flew past Europa, it started collecting data that completely changed how scientists thought about the icy world. One of the instruments on Galileo was designed to measure magnetic fields, and when the spacecraft passed Europa, it detected something strange. Europa seemed to be generating a magnetic response, not its own magnetic field exactly, but something that behaved like a conductive layer was moving beneath the surface. Now that's important, because there aren't many things in the universe that conduct electricity well enough to create that kind of signal. But one of them is saltwater, liquid saltwater. In other words, the data suggested that beneath Europa's frozen crust might be a global ocean, an ocean that could be 100 kilometers deep. To put that into perspective, the deepest ocean trench on Earth is about 11 kilometers deep. Europa's ocean could be almost 10 times deeper than that. And it wouldn't just be one ocean basin like on Earth. It would be global, a single ocean covering the entire moon. That's when scientists started to get very interested, because water is one of the most important ingredients for life. Wherever we find liquid water on Earth, we find life, even in places where it seems impossible. At the bottom of the ocean, inside frozen Antarctic lakes, deep underground, life finds a way. So if Europa has a giant ocean beneath its ice, the next question becomes obvious. Could anything live there? At first, that idea seemed unlikely. After all, Europa is extremely far from the Sun. Jupiter sits about 5 times farther from the Sun than Earth does, which means sunlight there is incredibly weak. The surface temperature of Europa averages around minus 160 degrees Celsius, cold enough to freeze almost anything solid. But then scientists realize something important. Life doesn't necessarily need sunlight. There are ecosystems on Earth that survive completely without it. At the bottom of Earth's oceans, thousands of meters below the surface, there are hydrothermal vents, cracks in the seafloor where hot water rich in minerals pours out of the planet's interior. Around these vents, entire ecosystems thrive. Bacteria feed on chemicals coming from the vents instead of sunlight. Larger creatures feed on those bacteria. Fish, crabs, giant tube worms, all living in total darkness. This process is called chemosynthesis. And if something similar exists on Europa's ocean floor, then the moon could potentially support life as well. But that raises another question. Where would the energy come from? On Earth, hydrothermal vents are powered by heat from our planet's interior. Europa, however, is much smaller than Earth. So where would the heat come from to keep an entire ocean liquid? The answer turns out to be Jupiter. Europa orbits extremely close to the giant planet, and Jupiter's gravity is enormous. As Europa travels around Jupiter, that gravitational pull constantly stretches and squeezes the moon. Scientists call this tidal flexing. Europa's orbit isn't perfectly circular. It's slightly elliptical, which means the strength of Jupiter's gravity changes during each orbit. So the moon is constantly being bent and squeezed. Over and over and over again. This constant flexing creates friction inside the moon, which generates heat. Enough heat to keep the ocean beneath the ice from freezing solid. In other words, Jupiter may be acting like a giant engine, pumping energy into Europa's interior. And if that heat is reaching the ocean floor, it could create the same kind of hydrothermal vents that support life on Earth. But the story gets even stranger. Because recently, scientists have started seeing evidence that the ocean beneath Europa's ice might not be completely sealed off. There may be ways for material from that ocean to reach the surface. And that's where things start to get really interesting. But the story gets even stranger. Because scientists are now starting to think that Europa's ocean may not be completely sealed off from the surface. For a long time, researchers assumed the ice shell covering Europa was like a solid lid, thick, frozen, and mostly isolated from the ocean below. But new observations are starting to suggest something different. The ice may actually be cracking open. And when it does, material from the ocean below might be leaking into space. The first hints of this came from the Hubble Space Telescope. Back in 2012, astronomers noticed something unusual while observing Europa passing in front of Jupiter. A faint plume appeared to be rising from the moon's surface. Not smoke, not dust, but something that looked suspiciously like water vapor. If that observation was correct, it meant that Europa might be shooting giant geysers of ocean water into space, similar to what we see on Saturn's moon Enceladus. And that would change everything. Because if water from the ocean is escaping into space, spacecraft wouldn't need to drill through kilometers of ice to study it. They could simply fly through the plume, collect samples, and look for signs of life. At first, scientists were cautious. The plume detection from Hubble was faint, and astronomers knew that false signals can sometimes appear when observing objects so far away. But then something interesting happened. In 2016, researchers analyzed another set of Hubble observations. And once again, they saw evidence of a plume, this time rising almost 200 kilometers above the surface. That's higher than the altitude where the International Space Station orbits Earth. And if Europa really is ejecting water from its hidden ocean, that means the moon may be far more active than anyone imagined. But plumes alone don't prove the existence of life. What scientists really want to know is what's inside that ocean. And that question brings us back to one of the biggest mysteries in planetary science. Because Europa's ocean might not just contain water. It may also contain energy. And energy is the second key ingredient for life. On Earth, life needs two basic things: liquid water and a source of energy. Without energy, biology simply cannot function. But the potential energy sources on Europa may be surprisingly powerful. Remember the tidal flexing caused by Jupiter's gravity. That constant squeezing doesn't just warm the ocean. It may also heat the rocky seafloor beneath it. If the seafloor is warm enough, it could create hydrothermal vents just like the ones at the bottom of Earth's oceans. And that's important, because hydrothermal vents on Earth support entire ecosystems. These environments are completely cut off from sunlight. Yet life thrives there anyway. Microorganisms feed on chemicals rising from the vents. Larger organisms feed on those microbes. And the entire ecosystem runs on chemical energy instead of sunlight. So if Europa's ocean floor has similar vents, the conditions for life might already exist. But scientists recently discovered something else that made Europa even more interesting. Something happening on the surface. When spacecraft study Europa's icy crust, they see long cracks and ridges running across the moon like scars. These cracks form because the ice shell is constantly shifting under the stress of Jupiter's gravity. But along some of these cracks, researchers have detected unusual chemical signatures. In particular, they've found evidence of salts and oxidants. These compounds are important because they can act as chemical fuel. If surface materials containing oxidants are transported down into the ocean through cracks in the ice, they could provide energy for microbial life. In other words, Europa might have a chemical cycle connecting the surface to the ocean below. Radiation from Jupiter's powerful magnetic field strikes the surface ice and produces reactive chemicals. Those chemicals then get transported downward into the ocean through fractures in the ice. Once there, they could interact with minerals from the ocean floor. And that combination, water, minerals, and chemical energy, is exactly what life needs. This idea has scientists extremely excited, because it means Europa might not just have water. It might have an entire ecosystem waiting beneath the ice. But before we get carried away, there's still a huge challenge: actually reaching that ocean. Europa's ice shell is believed to be somewhere between 15 and 25 kilometers thick. That's thicker than the deepest parts of Earth's oceans. Drilling through that much ice in an alien environment would be incredibly difficult, which is why scientists are focusing so much attention on those possible plumes. If the ocean is already ejecting material into space, we may not need to drill at all. And that's exactly what NASA is hoping to investigate with a new mission: the Europa Clipper spacecraft. Europa Clipper launched in 2024, and it's currently on its way to the Jupiter system. When it arrives, it will perform dozens of close flybys of Europa. Each pass will allow the spacecraft to study the moon's surface, measure the thickness of its ice shell, and search for active plumes. If plumes are present, Clipper may even fly directly through them. Its instruments can analyze the chemistry of the water vapor and ice particles. Scientists will be looking for specific molecules, organic compounds, salts, possible biosignatures, anything that might suggest biological activity. Even a simple microbial ecosystem would be one of the most important discoveries in human history, because it would mean life is not unique to Earth. It could emerge anywhere the right conditions exist. And if that's true, then the universe may be far more alive than we ever imagined. But here's the interesting part: Europa might not even be the only ocean world in our solar system. Scientists now believe there could be several moons with hidden oceans: Enceladus around Saturn, Titan, Ganymede. Even distant dwarf planets like Pluto may have subsurface oceans. The outer solar system, once thought to be cold and lifeless, may actually be full of hidden seas. And in those dark oceans, life could be evolving right now. But Europa remains one of the most promising places to look, because it has the right combination of water, chemistry, and energy. And it's close enough for us to explore. Still, we won't know for sure until we send spacecraft there and start collecting real data. And even if we do find something, it might not look anything like life on Earth. Life on Europa, if it exists, would have evolved in total darkness, under crushing pressure, in a world where the sun never shines. It might be microbial, or something even stranger. But the possibility is enough to keep scientists searching, because buried beneath kilometers of ice, in an ocean no human has ever seen, there might be something swimming right now. And if that's true, then the question we started with becomes even bigger. Have we really found signs of life on Europa? Or are we only just beginning to realize how strange that hidden ocean truly is?